нашу лекцию про научные коммуникации и научную журналистику в рамках Года науки и образования Великобритании и России. Сегодняшнюю лекцию организует посольство Великобритании в Москве, Политехнический музей и Высшая школа экономики, наш радушный хозяин. Я с большим удовольствием представляю нашего спикера, Julian Siddle, научный продюсер радио BBC, продюсер документальных фильмов, автор программы о новостях науки и медицины. Джулиан расскажет о своем опыте, о кейсах, с которыми он сталкивался, и после лекции, конечно, у вас будет возможность задать любые вопросы об устройстве мира, Вселенной, о научных коммуникациях, о науке, о том, что такое бозон Хиггса. Любые вопросы, которые вас заинтересуют. Джулиан, пожалуйста.
Yes, hello. So my name's Julian Siddle, as my colleague was saying there. I'm a science journalist for the BBC. At the moment, my main job is to make radio programmes, although over the years I've worked in other areas. I've been a reporter for news. I've worked on the news website. I've organised education campaigns and so forth. I'm not going to give a particularly technical talk today. I'm just going to give some examples of some of the kind of content that the BBC's produced around science and talk a little about some of the issues involved in science journalism and hopefully give you some of the ideas of a little bit about how we work and why we make decisions about things. Now, one thing I did last year and the year before was organise a large social media campaign for the BBC. This was social media around science, and it was at the same time as the mission to the International Space Station, in which we had British astronaut Tim Peake go for the first time. So we were able to do a lot with him to collaborate on this. I'm just going to show you a few of the short videos that we made with him to try and interest people in that mission. As soon as I can find the on switch. Oh, there we are. Okay.
Tim Peake is about to fulfill a dream.
I saw an internet article that said astronauts wanted, but I'd never appreciated that as a UK citizen you could become an astronaut.
He is the first Briton to join the European Astronaut Corps.
Finding out that I'd been selected was a real mixture of emotions. I mean, I was ecstatic, obviously. That was the overriding emotion was excitement.
Becoming an astronaut takes 6 years of the most demanding and rigorous training.
You do have to work hard. I come from a technical background. I love systems, I love aircraft, and those aspects of my training, EVA training, robotics, the Soyuz, I've lapped it up and enjoyed it.
For the past 18 months, Tim has kept a video diary revealing the risks and pressures he faces.
I've just had my first run in the centrifuge. I found it really hard to breathe. It's like having an elephant sitting on your chest.
Horizon has been allowed behind the scenes to follow Tim's training and his family as he prepares to say goodbye.
The closer you get to spaceflight, the more optimistic you get. The desire to fly increases. So when people ask me, are you nervous about flying to space? That's why I genuinely answer all the time, absolutely not. The thing I'm most nervous about is not flying to space.
So that was obviously made before the space mission even started, and we got Tim Peake to do a few things with us around that. We actually gave him a camera to take with him as he went throughout his training, and I'm just going to show you this one, which is in in the training centre that you may recognise, in fact.
This is the Prophy at Star City. It's where I've been living and spending an awful lot of time over the last 6 years. Here inside the entrance foyer we have this picture of the Soyuz, which has been signed by every astronaut and cosmonaut just as they leave this building and they head out to go down towards Baikonur. The Prophy has 3 floors. The first floor is for the Russians, the second floor is for NASA, and the third floor is for the European Space Agency and the Japanese Space Agency. So let's head up to the third floor. Dobrý den. As we come up to the third floor of the Prophy, we have the very rich history of European Space Agency flights. On this wall, every European astronaut that has flown has got their photograph and their mission patch. So this is my room number 33. Very comfortable, and in typical Russian fashion, there's always plenty of sofas and plenty of wooden furniture and display cabinets, which seems to be their thing. And through to the bedroom area. And there's also a loo and a bathroom through there. And the view looks out over towards the NASA cottages and the lake as well. Today actually I've been doing my Sokol fit check, my spacesuit fit check and seat liner, the final one before flight. Everything fitted really great. I was in the suit under pressure for about an hour, so I figure I deserve a cup of tea, so time to put the kettle on.
So I showed that to my colleagues who work for BBC Russian service, and they were like, wow, we never get to film in there. That's amazing that you managed to do that. So you might have noticed as well that Tim, during the video, he said, Dobry den. Of course, everyone who goes there has to learn a bit of Russian. So for a bit of fun, we thought we'd have a go at getting him to say that. I just remember this. I couldn't get this video to work earlier, so what I've done is I've just got it playing here in the background. Let's
Rocket. Raketa.
Raketa. Well, not too bad.
That sounds pretty good.
International Space Station. Международная космическая станция.
Very, very nice for a first timer. Well done.
That's a really long one. I think you did really well there.
Spacesuit. Scaphandra.
Scaphandr, not scaphandra.
They will understand what he means.
Liftoff. Поехали.
It's not the right word. But what is the right one in Russian? Not too sure.
Поехали is a famous phrase by Yuri Gagarin, the first spaceman. So, yeah, I'll take that.
Weightlessness. Невесомости.
Невесомость. Not невесомости, невесомость.
Tea. Chai.
Chai, yes, a very important word indeed.
Considering the short space of time he had to learn it, absolutely brilliant. And the most important word, chai, yeah, I don't know how they're going to brew it up there in невесомость, but, you know, I think it's going to be fine. Good luck.
Rocket. Raketa.
Because he's going to do all this again, isn't
well,
he?
not too bad.
That sounds pretty good.
No, that's enough of that, mate. Okay, so he... I'll just go back to the next one. Obviously, very entertaining, but it's not really got anything much to do with science. But what we were doing with it really was kind of building up a picture of Tim as as a character, really. I mean, he was very affable and so on, and we were. And that was all done before, of course, the launch of the thing. Once we got into space, then we were able to talk a little bit more in the collaboration with ESA about some of the science experiments that were going on. And just to give you an example, this next one, this is about some thing to do with irradiated seeds, where school children all around the UK were given some seeds that Tim took to space to grow after he came back, to compare them with
Now I'm looking after 2 kilograms
seeds
of
on Earth.
very special space seeds, which is ready for our special mission, Rocket Science, from the Royal Horticultural Society Campaign for School Gardening and the UK Space Agency. Now, conditions here on the International Space Station are quite different from on planet Earth due to us being weightless here in orbit. This experiment will aim to see if microgravity can affect the growth mechanisms in seeds. Now that these seeds have been on the International Space Station, I'll be packing them up at the end of their mission, sending them back down to Earth. And when they arrive, they'll be sent out to thousands of schools to grow alongside the seeds that haven't been up here in space as part of our special science experiment. These schools can then compare the growth differences between those seeds that have been flown in space and those that have remained on the ground. Now, if you want to have a go at growing these seeds, make sure you've signed up to the Rocket Science Project via the Royal Horticultural Society Campaign for School Gardening website. Good luck.
So it was actually really successful. I mean, millions of people watched the videos that Tim Peake made for us from the ISS and so forth, and it got us a whole new kind of audience on social media. Particularly, you know, for example, he's a dad and he was away from his family for months on end. So there was a lot of interest from parenting groups about that, and they became interested in the science, which I thought was quite interesting and unusual. But that campaign was not actually the most successful thing that we did. This is a video of well, it's a fish and it's dead. I'll explain to you a little bit about what's happening with it in a minute when I can. There we are, over there somewhere. Okay. So this comes from some scientific research into the decomposition of fish. This is actually in the Arctic. This was taken by filmed by the researchers involved, and obviously it's a time-lapse video of a fish being eaten and consumed over a period of days. What's really amazing about this is that it was a huge hit on social media. This went viral. 18 million people saw this in the space of a week. That's incredible. And what is it? It's a fish, a decomposing fish. Why did that create such interest? And I suppose there's various kind of factors which they show you how they did it at the end. There's the kit. But there's various sort of factors as to why that might work so well. I mean, firstly, it's unique. As far as I know, it's the only video of a decomposing fish on Facebook. There may be others, who knows, but I've not seen them. There are no words. It translates into, you know, any language, no problem. And it does tell a story, a very simple story about that thing. You know, whole fish, partly eaten fish, no fish, you know, get through it fairly rapidly. And I suppose for science, it's also useful in that it raises questions and answers a few as well. What does happen? What do whelks get up to on the floor of the Arctic Ocean? It opens up new areas of investigation. How does this kind of decomposition compare with other areas and so on? But, you know, for us, it was a way of really showing that you know, you can present science in a channel like Facebook in a way that reaches, you know, just massive audiences. I mean, the more traditional way that where we find our sources and so on for science journalism is through scientific papers. Obviously, these come out every week. There are embargoes and so on. I mean, I get a press release from the major journals each week. But the way that a science paper is written, of course, is just to appeal to people who are studying that area of science. It's not really aimed at the general public at all. So you get them written in a very technical way where it starts off with a very kind of broad kind of description of the area, and then right, you know, somewhere down the bottom you finally get the results. And in terms of reporting that science, we reverse that. I mean, science communication courses and things will talk about this technique called inverting the pyramid, which is essentially do the results first. And that's kind of what we do in terms of, if you imagine a headline written about something and so forth, like this. I'm going to just play you now an example of how we did this on a radio show. So bear in mind that was a scientific paper which was basically about discovering some more volcanoes than we thought there were in Antarctica, which itself is kind of a bit counterintuitive. You think, oh, that's a big lump of ice. Why would there be any volcanoes there? And of course, they're all underneath. Oops, sorry, I just went to the wrong one by accident. Let's find that again. Okay.
Well, you never quite know what you're going to find when you peek beneath the sheets. In this case, it's the ice sheets of the West Antarctic. Up to a mile under the ice, they found volcanoes. Not one, not two, but more than you might think, actually. Even these hardened scientists are surprised. The study has just been published by the Geological Society of London. One of the team is Robert Bingham of Edinburgh University, and he's been telling me that it all began with a question from one of the students in his group. As it turned out, a very good question.
We actually had a geology undergraduate student, Max van Beek de Vries. He's exceptionally interested in volcanoes, and he posed the question about what we knew about the locations of volcanoes beneath Antarctica. The answer to that was, well, not a great deal. We know that West Antarctica is flanked by volcanoes, but as we sort of had a conversation about where might volcanoes be beneath the ice, we realised that actually this has not really been investigated in the way that it could have been.
So that led to an investigation which presumably included trying to detect the characteristic conical shapes of volcanoes, which of course would be largely under the ice.
Indeed, that's correct, yeah. So the data set that we interrogated is actually a map of the bed topography, or the elevation beneath Antarctica. And this product actually is something that's been built up over many decades using ice-penetrating radar system to image through the ice. And we had never interrogated it in the way that we have now done, which, as you described, was actually looking for distinctive volcanic shapes.
What did you find?
We found 91 new volcanic structures beneath the West Antarctic ice sheet.
In your paper, you say that you can't use this method to definitively say whether these features are active. But it begs the question, doesn't it? The possibility that some of them might be. And we all know that fire and ice don't mix particularly happily in a place like Antarctica. Any risk there as far as we can tell?
Yeah, well, I think that subglacial eruption in Antarctica, I think the biggest effects that we might think about is the amount of water it would generate beneath the ice. Where does that water go? How does it contribute to whether the ice flow will accelerate in any given place? But we have to be very careful to distinguish between the facts that we know that West Antarctica is already thinning for sure, and the main reason for that is climate or ocean warming. And I think if we do find that there's a significant extent of active volcanism around all of these volcanoes, it's more likely to be a bit of a secondary effect than the primary reason for West Antarctica slowly thinning and contributing to sea level rise.
Like 91 confirmed volcanoes sounds a lot to me. Were you expecting to find that many?
No, not at all. We expected to find a fraction of that number, really. It's a real surprise to us.
So there's a number of kind of techniques and ideas there in how which we've used to present that in a way that takes it away from the scientific way it was done in the paper, and to try and make it appeal to a general audience. And there's stuff there that wasn't in the paper, the bit about the student having the question which led to the research, and also the putting it into the wider context of the ice thinning in Antarctica. And of course it's done in quite a conversational sort of way, because in a sense we've got to serve two different audiences here. We've got to serve people who know nothing about this, and also people who perhaps do know quite a bit about it as well. We've still got to maintain their interests. We don't want to bore or oversimplify it for them. So it's a kind of a bit of a balancing act, really, as to how much assumed knowledge you put in, and how much you explain it. And you notice that right in the middle of it, he asked a very specific question, which was basically just, what did you find? And it was a very short answer, which is ultimately the kind of the nub of the whole paper, really. There we are. Okay, but of course, I mean, science doesn't necessarily come just, from, or science news and the things we do don't necessarily come from scientific papers and things. Obviously, there's a lot from the real world as well. I mean, if you think about, every time, the example, the hurricane in the US at the moment, there'll be a lot of scientists popping up saying, what's going to happen with the weather patterns and all that kind of thing. But also, often it comes from quite sort of unexpected ways. In quite unexpected ways, we can suddenly be talking about science. I mean, like today, for example, is what's the date today? Yes, that's right. So, 9th of the 11th. Although.
Bring you in a moment, David, some of what they were telling us. But first, the full impact was seen in the moment in time. My colleague Stephen Evans, who was in the Trade Centre and was interviewed just after the first explosion.
that, there was another big explosion in the other tower. Flames coming out in this billowing grey smoke. People still not panicking, people not quite understanding what was going on. Then somebody said that they saw an airliner go into one of those towers. Then, I don't know, an hour later than that, we had that big explosion from much, much lower. I don't know what on earth caused that. The thing that strikes me is, one, the terribleness of the incident, whatever the cause, and we don't go into the politics, but whatever the cause, the terribleness, the hugeness of what's happened. So huge, in fact, that most of the people around simply can't understand what happened. People were just standing around, talking to each other, nodding their heads. Oh my God, we gotta go. Oh my God.
These pictures then.
I mean, it was an amazing bit of footage, really, as that tower started to fall behind him. But, I mean, at the time, I was working as a science reporter for BBC World Service News, and the question for me was, why on earth did that building start to fall down? You know, was there a scientific explanation? Because it's so amazing. I think even now, you know, you think of a plane hitting the building. But, you know, anyway, I mean, if something hit something here in Moscow, it's very unlikely that it would collapse in the same way that did. So, I mean, pretty much, you know, that afternoon, when this happened, I set about trying to find out why. And very quickly, I found the architect's firm that had designed it. They had a website which extolled the virtues of their design at that point, which was basically that it was kind of like a tube inside another tube. So there was a sort of a central tube around the lift shaft, and then there was another one which was the outer walls of the building, and nothing in between. The reason for nothing in between being that then gave you more area which you could, you know, rent out as office space and so on. And at the time, you know, their website boasted about this unique design. One of my colleagues, in fact, rang up one of the architects and to do a short interview with him, and in fact ended up telling him about what had just happened. He hadn't even realised. You know, it was like, turn the TV on and have a look. You know, pretty soon afterwards they took down their website. But you know, that was a remarkable day, I think, even for me as working as a science journalist on that story. I'm going to ask you a little. Let's skip over that one. I'm going to ask you a little question here now. This is about. I'm going to talk a little bit about forensic science and also about our perceptions of what science can do. So this is actually a picture of a prostitute. She was called Lynette White, and she was murdered in South Wales, in Britain, in 1988. Now, three men were wrongly convicted of her murder and released in the early 90s. But the question remained, you know, who did it? Blood samples were collected from the crime scene. This is in the 1980s, late 80s. So really, the techniques of DNA analysis were nothing like what they are these days. And it wasn't until 2002 that the police said, "We think we found a match." By that time, they'd established a DNA database, which was essentially where, if people were involved in crime, their DNA samples were taken, so they could compare it, and they found a match for the murderer in 2002. Except that the match was with a 14-year-old boy, so he wasn't even born at the time that she was killed. So have a little think about why that might be. We'll come back to that in a minute. I mean, forensics is amazing stuff. If you, I don't know if you're aware, the Bosnian war crimes trial, you know, which at The Hague, revolving around the massacres in Srebrenica in 1995, relied heavily on forensic evidence, but not from the bodies of those involved, but more from the environment. What it relied on was a team of specialists in pollen research, and what they'd done is, or what they were asked to establish was whether the bodies had been moved, because this was what the case revolved around. Essentially, that the accusation was that these 8,000 people had been killed in a particular location, and then their bodies had been moved, dispersed, buried elsewhere in order to hide the fact that they'd been killed. And those on trial claimed that, no, they were combatants and they'd fallen in the places where they were found. But what the pollen analysis showed, this is like pollen samples on the clothes and bodies, what it showed was that, yes, all that pollen came from one particular lowland place, the crops, the bushes, the grasses, and so on. That was all there. There wasn't any pollen from the areas where they were then buried. So it's quite powerful kind of evidence, really, and that's often used in cases where there have been attacks in parks and gardens and the countryside and so on, the pollen evidence. But we mustn't consider, obviously, forensic science to be completely infallible, because it's run by us, run by people. The science may be, black and white, but the way that we interpret it can be open to to bias and so forth. And a very good example of this this is a scientist called Itel Dor. He's a cognitive neuroscientist. And he was looking at this case of, there was an American lawyer called Brandon Mayfield, and in 2004, he was at the center of an international controversy because his fingerprints were identified by the FBI as being the same as those found on some bags of explosives used in a bombing in Madrid. So he's an American lawyer from the Midwest, and he was able to prove that there was no way that he could have been in Spain at the time that this thing took place. But clearly, some experts, fingerprint experts, had said they were his prints. Now, Itel went further and tested this. So he gave 2 fingerprint samples, which he said were from Mayfield and the bags, to 5 other fingerprint experts, and said, do you agree or not that these are the same prints? And only one of them agreed that they were. But Itel hadn't been truthful with them. What he'd actually done is he'd given them 2 sets of fingerprints from previous cases of their own, where they had said there was a match. And now, by him inferring that these things didn't match, they were agreeing with him. So, it's interesting. It's like, you think of the human error involved in these kind of cases where we've got to make those kind of judgments and so on. That's contextual bias or cognitive bias, as it's sometimes called. So back to that DNA case then with the prostitute. What do you think? Anybody got a suggestion as to what the answer might be? How is it that this 14-year-old boy's DNA was found at a murder scene before he wasn't even born? Say again? It was exactly. It was a relative. This is the thing. It was, in fact, it was his uncle. So when you talk about a DNA match, it's not necessarily, or in fact probably never, a perfect match. It's not like on the telly. It's not like the TV police who look, run that through the computer. Yes, it's exactly the same. It never is. I mean, here you're talking about a DNA sample that was collected. Actually a bit of blood on the wall that they found in 1988. They kept it until 2002, by which time the analysis techniques has improved enough that they were able to even look at it. And of course, it doesn't show everything. So some bits of it were the same, and some bits would have been missing. But it's still a match in the terms that there's some bits which are definitely the same. And then they looked at his uncle's DNA, and it was much closer. There were many more bits that matched. And the other factor which really kind of clinched it was that his uncle was in prison for murdering somebody else, and when questioned, did confess that he'd done it. Although, I mean, as it turned out, he in fact was in prison at the time that those 3 other people were wrongly convicted. So he could have said something, but obviously chose not to. I do a fair bit of travelling with my work. I'm just going to talk a little bit about this. The Hurricane Katrina story, this is from a few years ago. So the Mississippi is quite heavily controlled in terms of where the water control. There's lots of flood controls, and it's run by the U.S. Army Engineering Corps. And after the Hurricane Katrina sort of hit, it didn't exactly hit New Orleans. What actually happened was that it went around New Orleans, but New Orleans sits it's lower than the surrounding sea. It's below sea level, New Orleans. There's these kind of like, in America they call levees, these kind of like dikes or dams, and so on, which separate the New Orleans from the sea. And what happened was that over a period of in fact, the 3 following weeks, water sort of came back in through some holes in these dams and into the city and slowly filled it up. But everybody was saying, well, what's caused that kind of failure? I'll just show you some of the problem, some of what happened. These were taken a year later, which gives you an idea of the size and scale of the devastation. I mean, that's sort of fridges and things from people's houses that were flooded, and obviously a couple of American buses. 250,000 cars were destroyed in that flooding. And then this is the kind of thing that they've built since, which I'll tell you about in a minute. So the US Army Engineering Corps, they built a model of it. So this is what I went to investigate with my radio program. What was actually the real cause of it? Because there's a lot of sort of political discussion about lack of federal aid and things. But they built a scale model, 1/50th scale model of the New Orleans basin, and then they used a wave generator to flood it, basically to simulate the effect of the hurricane. And they found that the levee, the walls, collapsed in exactly the same places as they did for real in New Orleans. And they determined that it wasn't really the fault of the wall, but more the underlying soil, because there's not very much rock down there. So it's basically clay soil became very waterlogged and gave way underneath the walls. But they were able to say that they had previously, actually as far back as the 1950s, they'd asked for funding to shore up those walls to make the defences stronger, and this had been denied because the people living around it or just inside it didn't want that, because it would spoil their view of the lake, which was actually the estuary. Now, the fact that they had a view at all meant that they were on slightly higher ground than other people, and it was largely the other people that got flooded, of course. But since then, they've built this kind of thing. So this is some kind of massive sort of gate which rises out of the canal to close off the sea from the town, and then there's these huge pipes through which water is pumped out. So the idea is that if such a thing would ever happen again, then they can at least pump out the stuff. I mean, they have to do it every time it rains anyway, because it's, as I say, the whole city is below sea level. But for me, it was an interesting kind of practical scientific investigation, the analysis of that, which kind of cut through all the sort of the politics about whose fault it was. I mean, the Corps said yes, in a sense, it is our fault because it was our structure which gave way. But on the other hand, we'd asked to we'd been denied the funding to reinforce it in the past. Just go on to my next thing. I mean, one thing that's has been a big driver in terms of science is, of course, the space race, the Cold War, and so on. And in fact, to me, perhaps more so than any other event this century. I've got my own children to pose for this, by the way. I hope you like them. Yeah. But it's just to illustrate that. And I suppose what then happens is that scientists go like anybody would go where the money is. You can be adaptable. If you think of, I don't know, if you think of I was going to say about the scientists who discovered DNA. They initially were physicists who moved to a different field, and scientists are intelligent people. They can move from one field to another. So, and where there's the funding, I mean, create amazing things. You think of all the spin-offs from the science, from the space race in particular. And to me, the biggest one is the internet. So this is Leonard Kleinrock, and in 1969 he was responsible for making a computer link between the UCLA and Berkeley universities in California, which we now see as being the origins of the internet. That was the first internet link. that fridge-sized or cupboard-sized box next to him is a bit of technology there, the interface message processor, or IMP computer, which is basically now, of course, just on a microchip inside every internet-connected device that we have is this thing. And what it does is it's the beginning of, if you like, breaking up the data into little bits so that it can be sent off around the internet. And at the time, of course, 1969, it had to fill a room, you know. But he didn't know it was the internet at the time, and I don't think anybody did. But the reason they had the money to do with it was because of the US being a bit embarrassed about the current state of the space race for them in the mid-1960s. So they put loads of money into communications, and one thing in particular they were after was a kind of way of transmitting information around a network when there might be kind of a hole in it. Let's say if you were, I don't know, at war or something, and that's fundamentally what we still have with the internet. So that's kind of, I think that's really quite amazing, really, that to me. Anybody know what this is? I guess. What do you think? No? Science experiment from school? No? Thermometer, it's near. It's actually a barometer, but to be more precise, it's a model of the Torricellian barometer invented in 1644 by two of Galileo's students, who were Vincenzo Vivaldi and Evangelista Torricelli. So what they were doing is they were trying to understand the nature of water pumps and why there was a limit to how deep you could dig a well before and still pump the water out. And they made a kind of a laboratory scale model of the thing, but using mercury instead of water. And they noticed that it behaved in a way that we now recognise as being the basis of the barometer. And from that experiment, then, in a way, to me, that, like the internet, that's kind of a bit of world-changing science. Everything that we have before this concept of this, we had no idea what atmospheric pressure. We knew what it sort of was, but we had no way of measuring it. And then similarly, a bit later, we get the thermometer. But again, before that, the whole concept of what temperature was completely different. So I think it's a kind of a game-changing bit of science, and it's a good example of a bit of science that something happening sort of almost by accident in a way, I suppose, because they were looking for one thing and then they found another, and there are other examples of that we have in science. Okay, those are quite easy examples to understand, I think. Some science is really, really blooming hard. It's really difficult, isn't it? Stuff by Einstein is notoriously hard and difficult to understand. So from the point of view of science communication, should we even bother? Is it best to, should we try and interest the general public in the theories of Einstein or something, or should we just leave it to the experts? What do you think? Is it worth even bothering? I don't know. Have a listen to, this is Peter Higgs. So Peter Higgs, of course, of Higgs boson fame. Now just have a listen. He's going to talk here a little bit about the idea of trying to describe the Higgs boson in a simple way. As soon as I find that thing again. Gosh, this is hard, isn't it? Sorry for the delay in my finger. I don't know what I'm doing here other than trying to... Oh, there it is, up there somewhere. Okay, so I've got to take it back down there. Gosh, this is a science exercise itself, isn't it? There we go.
So, Peter Higgs, could you encapsulate the Higgs boson in, say, 30 seconds?
No.
If I stretched it to a minute, would that allow more time?
It still wouldn't work, I think.
What is for you the best analogy that explains it? Or the least bad?
Well, I think John Ellis's snowfield is about the best you can do.
So the idea is that the Higgs field is ground covered in snow, and the particles moving through it are people trudging through the snow with different sized snow boots.
That seems to be the idea, people getting bogged down or not getting bogged down with or without snowshoes or skis or whatever. At the other end of the scale, I object strongly to any mention of treacle.
So why is the snow analogy better than treacle?
Well, it gets rid of the idea of stickiness, at least. I mean, it may not do it completely, but particles going through treacle slow down continuously and lose energy. There's no loss of energy involved in any of this mass-generating mechanism. So some people are talking about the wrong thing though, when they're talking about something slowing down. Nothing slows down, and there's no suggestion that this is to do with viscosity or anything like that. So that's better.
There we are. So he, to find a simple analogy for what the Higgs is was, of course, the mission of many science communicators at the time of that discovery coming out. And, most of them were wrong in how they described it, just basically by trying to do it in such a small sort of, 30 seconds, say what it is, and it's really, really difficult to do. I mean, actually, obviously to understand it properly, we need to know a lot about the science, the background to it and so forth. But, I mean, in terms of to answer my own question about whether we should bother or not, the answer is we absolutely should. Because even if we don't get it completely right in terms of how we're communicating it, or we don't communicate all the information in the 30 seconds we have available, say, if we're talking on a news show or something, it is of phenomenal interest to the general public. This was a massive story around the whole world. People were really, really interested. Loads of. I was talking to a newspaper editor who told me that it was putting the Higgs boson on the front page. They sold more copies of this paper than they'd ever had before. He didn't really understand why, and I said, well, people are actually really fascinated by science, and in particular these kind of these really big, profound kind of questions where it shows us as being something quite small within the entirety of existence and so forth. I'll play this other example here, gravitational waves. Now you might know Brian Cox actually if you've seen some of his TV shows.
But what exactly is a gravitational wave? It's not that easy to describe. If a wave came through this room, it'd what did I say? Ripples in. Space-time isn't just something that's up there amongst the stars. It's here, right? It's in front of me and it's inside me. So when I move, I disturb it. I send out ripples in it. It's just like if I jump into a swimming pool and start swimming, I'll send out ripples on the surface of the water. It's the same with space-time.
It's the same with space-time, apparently. So there we are. That's clear, isn't it? So Brian, you might know him because he fronts a lot of BBC science programmes. His job is, he has an academic job. He's the professor of the communication of physics at Manchester University. He doesn't study physics, but his job is to communicate it. And there he is, having considerable difficulty with the concept of gravitational waves, which I do find. I was once asked that question in a job interview, actually, many years ago. What are gravitational waves? And at the time I sort of thought, all right, well, I'll say something about ponds and pebbles, and I kind of said this thing, and they all nodded sagely, because they had no idea either, people I was talking to. But, it's really difficult. I think that when that story, the LIGO thing, people will go, well, no, what's space-time? What's that? And it's like two words, space and time. What does it mean? What does it mean? But there's huge fascination in it all the same, even if it, I suppose what I'm saying is explain what you can, because people can always find out more if they're really that into it. But it's all about how much time have you got and so on. It's easier to do this thing if you're writing about it in some way than particularly for me trying to do it as a broadcaster or something. Again, to explain gravitational waves in 3 minutes is quite hard, I would say. The other end of things is that really another area of, the other area of science that people really, really engage with is things that affect us personally, and in a sense, this is the whole area of health largely. The discoveries about health. I was doing this earlier we had a workshop in which we discussed a paper which showed signs of autism in some experiments with mice. People are going to be very interested in that because that obviously affects a number of people, a number of us as humans. But the whole thing. I mean, this girl is in Sierra Leone, and this is her response to the intervention over Ebola there. Which was a kind of a massive sort of global effort involving all kinds of scientists. So it's not just people on the ground, but also epidemiologists and statisticians and the people who develop antivirals and so forth. That health stories are a really good sell in the sense that they're very personal. So I mean, if you're thinking about your science content that you're being asked to promote or to push to a general audience, then thinking about does it have some massive kind of game-changing potential like the gravitational waves or the Higgs boson, or does it appeal very personally? I think those are two areas where you can really, where people will be very, very interested, I think, all the same. So, I mean, I'll take a few questions in a minute, but I'll just leave you with a few thoughts, which are, I mean, my own idea really on where scientific development is going is, I think, in a sense, a bit like the way that the World Wide Web and email and everything crept up on us. So suddenly we were all suddenly using it without necessarily realizing that this thing had happened and had taken over the world. I think that the coming together of computing power and biology is going to kind of do the same thing. I don't just mean in terms of literal physical connections between the two, although that is happening, with sort of little robots that can flow through your veins or something. But just having that massive data crunching ability that we now have. I mean, I did a piece recently about modelling, multi-dimensional modelling of the brain, of human brains, which essentially used masses and masses of computing power to produce these models, not in 3 dimensions, but more. I still don't quite understand how and why, but it's still something which wouldn't have been possible even sort of 5 years ago or something. I'm just going to end by playing you this amazing video of this guy. So this is a man who is paralyzed from the neck down, but he's got a couple of implants in his head, and he's basically controlling this robot arm with them. Oh, now what have I done? Turned it off by accident. Okay, not just yet. Yeah.
Very good.
Cheers. If you can see that device sticking out of his head, that's what he's actually using to control it with.
Finish that thing off. That's good. And that's how science is made. All right.
There you go.
Did it! Did it!
Thank you. I'll take some questions.
Друзья, теперь у вас есть возможность задать вопросы. Поднимайте, пожалуйста, руку. Я подойду с микрофоном.
Hi, my name is Natalia. I have a question. What is your opinion? Why science communications become more and more popular recent years? Maybe it's because of general population, as you said, is tired about politics, terrorism, economics, everything, and they are more interested in this dream world of science.
That's quite interesting. Yes, I think essentially, I think it's partly to do with the sort of new kinds of media coming along. Actually, I mean, I talked at the beginning about social media. that science is hugely popular in social media. People are just interested in it, and they share things with each other, for example, and that's not being controlled by a usual sort of traditional news media editorial kind of controls where they, you know, I mean, the classic thing I mean, I've found this myself as a science reporter, is that, you know, your news editor is somebody who really doesn't get science, or is a bit scared of it, or wants it to be a funny story at the end, you know, and that geopolitics is the most interesting thing, and, you know, that's what it should all be about. And actually, wow, they're finding out that when the audience has the choice, they choose the science instead. It's interesting with something like the BBC News website, for example. We have there's a science section, and you can see what's most popular. There's a little bar. It just says most popular, and often it's the science, and it's beating whatever the story is about, you know, something else. I don't know. I remember a particular incident of North Korea had just bombed the South, okay, and that was less popular than a story about. It was an interview with somebody. It was about a boy who'd been brought up as a girl. You know, I mean, it's a very soft science story, if you like, but you even say, you know, there we are. That's what people were looking at, not North Korea bombing the South. Boring, you know.
Пожалуйста, еще вопросы?
My name is Andrei, and I have a simple question. You said that a lot of people are fascinated by science, but at the same time they consider science as a threat. For example, genetically modified products or nuclear energy. How do you explain this dichotomy, or whatever it is?
Yes, it's true, and it's a really fascinating area, isn't it? Really, that, you know, I think. There's a lot of misinformation about those subjects, and in fact, I mean, in a sense, there's so much misinformation that we tend to, you know, that those sort of urban myths of it become the accepted truths. I mean, if it's genetic modification, for example, there are no commercial crops grown anywhere in the world that don't do anything other than they're all genetically modified against herbicides. So the idea is that, you know, you spray the crop and it kills the weeds, and the crop continues. That's it. That's what the GM bit is about. It's not about, you know, creating monsters or whatever. You know what I mean? And people don't get that. You know, there are other functions of GM that exist, but those are the only ones that have really taken off commercially. You know, it's quite funny. Think of the arguments over, you know, what's better, conventional versus organic food or something like that, and, you know, people are scared of radiation and things like that. So, you know, I don't know. It's a hard one. It's a really hard one, and there are whole pressure groups about these kind of things. We in Britain we have this kind of scandal to do with vaccinations, in which a doctor published a clinical trial in which he claimed there was a link between certain kind of vaccination and autism, which was then found later, of course, to he was actually being funded by some drug companies that made individual vaccines rather than this combined one, and had made up some of his results, and he was eventually struck off. But people still believe that what he said was right, and they think that there's a link, and as a result of that, lots of people didn't get their children vaccinated, which is, you know, that's an incredibly dangerous side of misinformation of science.
That was a fake.
The guy was a fake.
I mean, you said that this is not true. There's no connection between vaccination and autism.
Yes, but what he'd done is he'd actually had a paper. He'd run a trial. It had been peer-reviewed and published in the Lancet, leading medical journal. So for a while, lots of people believed it. And then as people investigated his research further and looked at, you know, trying to replicate it or so on, they found out that, you know, at the heart of it was a political agenda, you know, and some sort of drug company money. So he just, you know, and as I say, as a result, he was struck off. He's no longer allowed to practice medicine. But, you know, it caused a real problem in that a lot of people believed that, and, you know, there were outbreaks of disease because of people not being vaccinated. So I mean, there's a, you know, we have this all the time. I mean, you know, we in a sense, there will always be somebody who will say, who has a particular view, and it's not based. I mean, science it's evidence based, and this is the thing, isn't it? Whereas there are stories which people believe which have nothing to do with evidence. I mean, the one that's perhaps the most, I just suddenly thought of this crazy thing is in the US, creation science is particularly, is taught in schools, in some schools, which is this idea of, the world is between 4,000 and 6,000 years old, Noah's Ark, we put everything on it, including the dinosaurs, and then you can find it somewhere in the Grand Canyon, and, just this nutty story. It's a great story, but it's a story. And, this is taught in schools as a valid alternative to evidence-based science. It's just amazes me, really, that happens. But anyway, it's a political thing, too. Sorry, it's a rather ranty answer.
А есть ли еще вопросы? Кстати, можно задать вопросы по-русски. Наши замечательные переводчики переведут их для Джулиана.
Добрый день. Скажите, пожалуйста, а есть ли какие-то особые навыки, знания, которые нужны журналисту, чтобы быть успешным на этом поприще, доносить научную информацию до широкого круга людей?
Well, I suppose as well as the general ones that you want for kind of reporting on anything, like being able to articulate the subject well, being able to translate it into simple everyday language, I think you do need a certain, either you needed a certain knowledge base of science. I'm not saying you need to be an expert, but you need to be aware that of what sort of some of the fundamental questions within science might be, or how to take a piece of research and kind of sort of test it against, to find out. I'm saying, I mean, if you're not an expert in a certain area, then you need to be aware that you need to go and find somebody who is, to give you a reality check about it, really. So that's kind of a kind of a research kind of a sense of being able to do the research. But rather than, I mean, a lot of the problem with things being wrong, I think, often comes from where people just assume stuff without really checking it out. So I think fact-checking, thinking, in a sense, thinking about things scientifically, thinking about, what's the evidence, where does it come from, that kind of thing, rather than just kind of going with a good headline. I think that's perhaps the key thing. Yeah.
Джулиан, большое спасибо за лекцию. Как, на ваш взгляд, можно говорить о науке для детей, чтобы им это было интересно? На мой взгляд, научная журналистика – это способ говорить с неучеными о науке интересно, а говорить с детьми о науке, наверное, еще более большой вызов. Как, на ваш взгляд, это делать интересно, есть ли какие-то особенности в общении с детьми, в коммуникации науки? Спасибо.
Okay, so I would say practical demonstration is your key here in the classroom and so forth. So I showed you two of my children earlier. The eldest one is going to be 9 in a couple of weeks. And I'm going to take him he's having a birthday party in a science centre. Not because I'm a particularly geeky person. It was actually him who wanted to do it. He was very excited about this place, which is near where we live. It's got some kind of like planetarium things. They have a party room, which is actually a geodesic dome. And there's a lot of kind of, science explaining stuff set up for school children in it. Which is very practical. It's like have a go, and then we explain how it works. So I think that's absolutely the key is involve them literally in it with some kind of practical demonstrations.
Остались ли еще вопросы? Нет? Да.
Thank you so much for your lecture. I have a question. As you know, Elon Musk published on Twitter the
information that, like, his thoughts that artificial intelligence will lead us to the Third World War, and it's like there is the same thought by Nassim Taleb. What do you think about it, and how we need to deal with it? What do you think?
Well, they're entitled to their own thoughts. I don't think that at the moment that there's anything particularly, that we can do other than, we could have a discussion about what they think if we want. But as it's to me, it's largely in the realms of fantasy. Where do we go with it in terms of evidence-based science? I think it's very difficult. It's always hard to predict the future. And I mean, artificial intelligence will lead to what? I don't know. I made a radio program recently in which it was on the history of the internet, and I talked about what might happen in the future. And what we talked about there was issues with security on the Internet of Things, but it was more things like if you have an internet-connected fridge, then make sure it's got a secure password just the same as you would have on your computer or your phone, because that can be hacked too. There's a big thing with people trying to hack baby monitors. I don't know if you know about these this sort of like Bluetooth sort of baby monitors that you can get, where they're all kind of you buy one, you plug it in, but actually it's got a password which you can change, but nobody ever bothers to. So potentially they are botnet of baby monitors. Launching some kind of cyber attack is probably more of an issue than World War, I would think. Yeah.
Спасибо за выступление. Было очень интересно послушать о вашем опыте. Это всегда полезно для всех. А вопрос следующий. И журналисты, и дети всегда пытаются заглянуть в будущее, опередить события. И такой детский вопрос. Да? Как вы думаете, какие открытия ожидают нас в ближайшее время?
Like I said, to repeat what I said for the last question, I don't know. I mean, what kind of discoveries are we expecting soon? Well, like I said at the end of my talk, I mean, for me, it's things to do with a deeper understanding of biology brought about by computers. But where that actually, in the end, will take us, I don't know. But I think that's happening now. How people apply it and so forth. So I think we just won't know, or we don't know yet.
Еще кто-нибудь хочет что-нибудь спросить у Джулиана? Да, можно. Еще один вопрос.
Actually, this was my main question to you about this 14-year-old boy. How his DNA tests appeared in database of forensic and criminal police?
Yes, well, despite the fact that he was 14, he was already a criminal of sorts. He was a petty thief. He'd been not involved in stealing things. He'd been caught, that kind of stuff.
I thought that he would be an angel somehow.
Все, вопросы закончились? Прекрасно. Тогда давайте поблагодарим Джулиана. Большое спасибо нашим переводчикам, которые работали с нами весь день. Аплодисменты переводчикам. Спасибо Политехническому музею, спасибо посольству Великобритании, спасибо Высшей школе экономики. Если вы захотите поучиться в Британии, стипендия Achieving для вас. Найдите информацию или подойдите к Насте, она вам все расскажет. Настя, помаши рукой. Да, стипендия, чтобы учиться в британских вузах. Спасибо, что пришли. Надеюсь, было интересно. Участвуйте в других мероприятиях Года науки и образования Великобритании и России. Ну да, и задавайте наушники, не забирайте, пожалуйста, с собой. Спасибо.